Okay, so I'll be going through this P5 Red Swastika 2023 paper. It is a WA2 paper. So let's begin. So first question, what is the value of the digit 4 in this number? Okay, so this should be a very straightforward one. Our 4 is in the 100,000 space. So this is your thousands, this is your 10,000s, and this number 4 is your 100,000. So that means the answer is number 1, 400,000. Okay, question 2, 505 times 400. So to do this without the calculator, you can ignore these two zeros first. Okay, you can settle 505 times 4 first. Okay, so if you do the calculation, you realize that this gives us 2020. So these two, the last two zeros in the 400, you just need to place it back here. So your number is this much, 2 million, is it 2 million? No, sorry, 202,000. Okay, so this 202,000, so that will be number 3. All right, and the next one would be express 3/20 as a decimal. So to express a fraction as a decimal, you need to first make the denominator into 10, 100, or 1,000. So in this case, I think the best is to make into 100. Just multiply by 5. You will get 15 over 100, and then you can put it as a decimal, which is 0.15. Okay, so that's number 3. All right, let's go on to question 4. Find the value of 6 over 5 times 30. Okay, so 6 over 5 times 30, you can rewrite 30 as a fraction. So 30 as a fraction is 30 over 1. All right, and with this, you can apply the cross cancellation method. So look at 6 and 1 first. So between 6 and 1, there's nothing to cancel. What about between 5 and 30? So between 5 and 30, both numbers can divide by 5. So 5 divided by 5 turns to 1, 30 divided by 5 turns to 6. So once this is settled already, you can just multiply the top with top, bottom with bottom. So 6 times 6, 36. Bottom is 1 times 1 is just a 1. So this answer will result in just a 36. So 36 over 1 just means 36 divided by 1. Okay, so answer is 4. All right, the next one, which of the following has the smallest value? All right, so to decide for smallest value, you can go on to do the calculation. I mean, that's one way. You can calculate for everything and compare which one is the smallest. Okay, alternatively, some of you may prefer to just look for options that have similar terms. So what do I mean by that? Okay, so for example, the first two options, notice that the similar term is 6 over 5, 6 over 5. So now you just need to compare with the times 10 over 2 and the times 10 over 4. Okay, this is one way. But if you don't like to do it this way, or if you feel that you're not so confident at that way, then you just need to calculate everything out, which I think is okay also. All right. Okay, so I think I will do the calculation for all. All right, so what I'm going to do is I'm going to just do the cross cancellation method. So 5 and 10. Okay, let's do 5 and 10 first. Both can divide by 5. So divide by 5, you get these two numbers respectively. Next one be 6 and 2. 6 and 2 can divide by 2. So this becomes 1, this becomes 3. Okay, so actually it's pretty fast once you are very good with the, you're very good at this cancellation thing, then it's pretty quick. Okay, so 3 times 2 is 6. 6 over 1 is just 6. Okay, so that's for the first option. Second option, 5 and 10, again, both can cancel. 6 and 4, again, both divide by 2. So this becomes 3 times 2 is 6 over, bottom is 2. So 6 over 2 means 6 divided by 2, which gives us a 3. Okay, so obviously option 1 is out already. And the next one, same, 8, 2 first. 8, 2, both can divide by 2. Divide by 2. Next will be 10 and 5, both can divide by 5. This one also divide by 5. Okay, so do the multiplication. 2 times 4, over 1 times 1, which gives us a 8. Last option, 5 and 10 cancel, become divide by 5 away. 4 and 8 can divide by 2. Sorry, can divide by 4 actually. Okay, so 4 and 8 can divide by 4. Let's do that. Okay, so top times top, bottom times bottom, this gives us a 4. So as we can see, the option that gives us the smallest value is option 2. It gives us a 3. All right, let's look at the next one. Okay, so the next one, 100 chairs cost $6,000, 20 tables $9,000, and you need the total cost of 1 chair and 1 table. Okay, so let's work out 1 chair first. So 1 chair simply is $6,000 divided by 100. Okay, so for this to do the division easy, you don't have to do your long division. Just check for common number of zeros at the end. All right, so you see 6,000 and 100 have 2 zeros at the end. Just take away both zeros. And you can go on to evaluate 60 divided by 1, which is $60. We're going to do the same for 1 table. So 1 table will be $9,000 divided by 20. Okay, same logic. You can look out for the common number of zeros. So 1 0, 1 0, cancel away. Then whatever is left means 900 divided by 2. So 900 divided by 2 will give us $450 if you do your long division for this. Okay, and of course, just work out the total cost of 450 plus $60, which is $510. Right? Okay, question 7. Okay, so question 7 says total length of a wire and a rod is 4.5 meters. The length of the wire is 1 1/3 meters. So find the difference in the length. Okay, so currently wire is given, total is given. So what we don't have is the length of the rod. I think we need to work this out first. Okay, so since total is given 4.5, you got to subtract this wire away to get the rod. All right, so during subtraction, as you know, you have to make the denominators the same. So both denominators will be a 6. So times 3 for this. Next fraction times 2 times 2. And you get 3 and 1/6 meters. This is for the rod length. Okay, don't stop there. Remember the question asked for difference. So you need to take the difference between the wire and the rod. So the difference between these two, just subtract. All right, same thing when you do subtraction, make sure denominator will have to be the same. So 3 and 1/6 meters minus 1 whole n 2/6 meters. Now, when you do subtraction between mixed numbers, be careful. The first numerator has to be able to subtract the second numerator. Right at this point, I notice 1 cannot minus 2. So if 1 cannot minus 2, you have to try to make this guy a bigger number. How to do that? He has to borrow 1 whole from his friend here, from the 3 here. Okay, so that means 3 wholes will turn to 2 wholes. So that means if I give 1 whole to 1/6, I'm giving 6/6 to him, to combine with him. So 6/6 with this 1/6 becomes 7/6. All right. And now you realize 7 can minus 2 already, so very nice. Okay, whole minus whole first. So 2 minus 1 is 1. 7 minus 2 is 5. Okay, and this is your difference, number 4. All right. Okay, let's look at question 8. Okay, question 8. So we have this equation here whereby A and B are missing digits. They are in fractions. Okay, so which of the following are possible numbers under each of those stickers? All right, so how do I work this out? All right, so the key to this is this. If notice that when in fractions, right, when you take 2 fractions multiply each other, we know that when these 2 numerators multiply together, okay, the answer has to be a multiple of the 2 here. So that means 4 times b has to be a multiple of 2. Okay, so 4 times b can be like, for example, 4 times 3. 4 times 3 is 12. 12 can eventually simplify to get 2. So 12 is a multiple of 2. Okay, so I'm just giving you an example for now. All right. Whereas for the bottom, see my dear, a times 6 must give you a answer that has that is a multiple of 9. Okay, so the key is this, right? The answer to, okay, let me just type out answer to 4 times your b must be a multiple of 2. And the answer to a times 6 must be a multiple of 9. Okay, do write this down if you didn't manage to solve this. So now what we can just do is we can test out the options one by one. Actually, if you just test A, it's good enough first. Okay, and if you notice, if you test out using A and the multiplication doesn't give you a multiple of 2, then you don't need to test B already. All right, so we look at the first one first. Okay, actually, if you want to test, sorry, A is the bottom one. Yeah. So sorry, A times 6 should be the answer should be a multiple of 9. Okay, my mistake. So A is the bottom. I didn't realize that. Yeah. Okay, so let's test out A first. So A, let's pretend if it's a 2. So 2 times 6. 2 times 6 is 12. Notice that 12 is not a multiple of 9. Right? That means option 1 is out. I don't even need to test B. Don't need. Okay, let's go on to option 2, 3. Let's test out 3. So 3 times 6 is 18, right? 3 times 6 is 18. 18 is a multiple of 9. So option 2, we can keep it in mind, but we should go on to test out, option B then. Sorry, not option B, the number for B. Okay, so if let's say, okay, I'm just going to write down. So 4 over 3. Okay, let's put 2 inside B, so times 2 over 6. Okay, let's do the cancellation, see whether it works out to be 2 over 9 eventually. So 2 and 3, nothing to cancel. 4 and 6 both can cancel, become this. Right. And you notice the multiplication here actually gives us 2 times 2 is 4 over 9, which is not 2 over 9. So that means option 2 is out. Okay, option 3, you look at A first. A is 12. 12 times 6 is 72. 72, yes, it is a multiple of 9. So it's possible. Okay, so let's do the test for B then. Throw the numbers into the equation. B is 4. 6. Okay, so let's do the test. So 4 and 6 cancel, divide by 2 away. 4 and 12 can divide by 4, like that. Okay, so if you simplify this is 2. 3 times 3 is 9. So you see, option 3 is the correct answer. Okay, so you don't even need to test out option 4. But if you would like to go on to test out option 4 just in case, yeah, please just do it. You can go ahead and do it. It's fine. All right. Okay, let's go on to question 9. Tommy had 60 marbles. 1/4 of the marbles were red and 1/6 of them were green and the rest were blue. Okay, so take note of the marbles. The marbles is referring to the 60 marbles at the start. Same over here, 1/6 of them. The them is referring to the 60 at the start also. Okay, so I'm just going to work out the number of red marbles. So if you ask me, do I need to draw model for this? No need. Okay, because if I draw model for this, that means your common denominator 4 and 6 will be 12 units, which is a little bit troublesome. But of course, if you do that way, it's fine also. So today we are going to learn it another way. So 1/4 of the marbles were red. We're going to straight away calculate the number of red marbles by dealing with these two values. So when I say 1/4 of the marbles means 1/4 of the 60 were red. So 1/4 of 60 means you can just take 1/4 multiplied by 60. Okay, now how to multiply this? You can do the cross cancellation way. 60 is like 60 over 1 lah, correct? Then the 1 and 1, nothing to cancel. So 60 and 4, notice both can divide by 4. So both divide by 4 gives you a 15. Okay, so 1 times 15 over 1 is just 15. So there are 15 red. This is what you found. Okay, the next one will be 1 over 6 were green. So we're going to work out the number of green marbles. Same thing, 1 over 6 of them means 1 over 6 of the 60, which means you can take 1 over 6 multiplied by the 60. Okay, let's cross cancel again. 6 and 60 both can divide by 6. So this divide by 6, this divide by 6. And this gives us a 10, 1 times 10. All right, so 10 green marbles. All right, so red and green together is 25 marbles already, right? So now they want the blue ones. Total is 60, right? So just take your 60 minus your 25. And there you go. All right. Okay, let's look at question 10. Mrs. Lim bought 3 kg of flour. She used half of it to bake a cake. She used some flour to bake a pie and had 8 kg of flour left. So notice there are 3 things here, cake, pie, and left. All those that I've highlighted are all parts of the 3 kg at the start. So 3 kg is like the whole. The rest are the parts belonging to that whole. Okay, so let's settle the mass used for the cake first, because right now I think we don't have that yet. Okay, so she used half of it. Of it means the it is referring to the 3 kg at first. Okay, so she used half of the 3 kg. So I'm going to just take half multiply by the 3 kg. Or alternatively, some of you want to take 3 kg divide by 2. That's all right also. Divide by 2 is the same as times half also. Okay, so for this, you can't really cancel anything, but that's okay. You can just take the top times top, bottom times bottom. Bottom is just over 1. So it's just 3 over 2 kg. So you have found the mass used for the cake, which is 3 over 2 kg. You can leave it like that first, or if not, you want to leave it as a mixed number, also can. It's up to you. Okay, so we have the left also, 3 over 8 kg. So take note, luckily this is already in kg also. So please don't go and take 3 over 8 times 3 kg, that's wrong. This is already kg on its own. It's a mess. Okay, so now straight away you can find the pie, the use for the pie, by taking the total at first minus the cake, the mass of use that's for cake, and minus the mass that is left. So that's how I can eventually get the pie. All right, so 3, you can rewrite it as 3 over 1 first, right? 3 itself is 3 over 1. Then the next 2 denominators, I'm just going to make into common 8. So this will be 12 over 8 kg. Last one, no change, just bring down. Okay, and the first fraction, I'm going to make it into denominator 8 also. So times 8 will be 24 over 8. Like that. Okay, so proceed to do your subtraction. 24 minus 12 minus 3. That should give us a 9 over 8 kg. And just change to a mixed number and you get this. And just nice, it's the simplest form. So number 1. All right. Okay, we shall move on to question 11. So find the value of 45,000 divided by 60. All right, so a bit like one of the questions we did earlier. When you do the division, check for common zeros to take away. So 1 0, 1 0. Okay, and then proceed to do your long division for 4,500 divided by 6. Okay, so I'll show you all the long division here. All right, so 45 divided by 6 is 7. Another 0. 30 divided by 6 is 5. Okay, and of course, this gives us a 750. Okay, so that's it. Next one, order of operations. Solve the brackets first. Okay, so look at the bracket first. We're going to settle this first. So inside the bracket, there's minus and times. Of course, you have to solve the times first. Alright, so when there's a mixture, then see which one to solve first inside the bracket. So solve the times first. So 1 times 2 is just 2. So 5 minus 2 is a 3. Okay, so that's just a 3. And now you can go and look at the front So no more brackets. So now if I were to rewrite it, it looks like that. Okay. Now next thing is look from left to right. So left to right, notice that I have plus and then times and then divide. So which one takes priority at this point? So the one that takes priority is this 6 times 8. Okay, plus of course it's not. Then next one is times and divide. So times and divide have the same rank. Depending which one comes first, if times come first, you solve times first. If divide comes first, then you solve divide first. So in this case, times come first. Okay, so I am going to calculate that out. Okay, so 4 is just 4. Then 6 times 8 is 48. Then bring down the divide by 3. Of course, then the next one is solving your division, right? So plus and divide, of course, divide comes first. So 4 plus 48 divided by 3 is 16. Then finally, you can add this two up. So your answer is 20. Okay, next, find the value of 30 divided by 8. Express your answer as a mixed number, so they want a fraction. Okay, so remember a division itself also acts as a fraction. So 30 divided 8 means you can put it as 30 over 8. Now you can go on to either change the mixed number first, or you want to simplify this fraction first. It's up to you. Okay, so for me, I decide to simplify first. Both top and bottom can divide by 2. Divide by 2 gives me 15 over 4. Then I go on to change to mixed number. Okay, so make sure it's simplest form. The question wants that. Okay, question 14. So question 14, in the number line A and B are mixed numbers. Find A. All right, so notice that along the number line there are many points and markings, many gaps also, and the two numbers that they have given us is 1 and 4. Okay, very far away. So what you can consider doing is use the intervals concept method. Okay, intervals concept. All right, so how do I begin? From 1 to 4 first, look at how many intervals are there. So an interval is a gap. Okay, one interval means one gap. So if you count the number of gaps, 1, 2, 3, 4, 5, 6, 7, 8. There are a total of 8 intervals. Okay, so we're going to work out 8 intervals, the value in these 8 intervals. Okay, I'll just put int for short. So to find 8 intervals value, you have to take the difference between the two numbers here. 4 minus 1, right? Which is a 3. Now, subsequently, you can work out the value of one interval first. So this will be very helpful. This one interval will subsequently help you solve towards A and B. Okay, so to find one interval means you have to take your 3 divided by 8, which in this case, just leave it as a fraction, 3 over 8. How I know divide by 8? Because this is a total value of 3, you're splitting up among 8 intervals. So it's like finding 1 unit, 8 units, 1 unit, then you take right side number divide by 8. All right, same idea here. So now we're going to work towards A. So to get to A, look at the starting one. From 1, you must count how many intervals to get to A. So I count 1, 2, 3, 4. 4 intervals to get to A. So we calculate what is 4 intervals first. Okay, so 3 over 8 times 4, right? Which gives us, if you want to do the cancellation, you can go ahead. So cancel become 1, cancel become 2. Okay, so this gives us 3 over 2 for 4 intervals. Okay, so don't stop there. Remember, this is just the value of 4 intervals. Now you have to get to A from 1. So from 1, you are moving forward by 3 over 2 steps. So to get to A, you have to take your starting 1 plus this value of 4 intervals plus the 3 over 2. Okay, so if I were to rewrite this means 1 plus 1.5. The 1.5 is the 3 over 2 lah. So this 2 is the same thing. Okay, so just add them up, you get 2.5. So that is your answer. Alright, the next one is find A plus B. We have found A from earlier, so now we need to work out what is B. Okay, so to work out B, actually, you can just use 4 whole minus the two intervals value to get to B, or you can use from A, assuming if your A answer is correct lah, then you can use from A to move forward 2 intervals to get to B. Either way, it's fine. Okay, so let's say for B, I want to use starting from A. So 2, or you want to use from 4 wholes, okay now. Okay, so 4 whole, maybe I use for 4 wholes, minus away 2 intervals. So 4 whole minus 3 over 8 and 3 over 8. So minus 2 times of 3 over 8, right? So that means 2 times of 3 over 8 will be 6 over 8. Okay, because this is 3 over 8, 3 over 8. So together you're moving back 6 over 8. Okay, so we shall rewrite 4 as 3 wholes and 8 over 8. So basically I rewrite it as a mixed number. I take out 1 whole to rewrite it as 8 over 8. Okay, then now you do the subtraction, 3 whole and 2 over 8. Can simplify to 3 and 1/4. Okay, so once we have this, you can finally add A and B already. So A plus B. Just add them together. So 2.5 plus 3 and 1/4. This one times 2 times 2. This one no change. Okay, and you get 5 wholes and 3 over 4. All right, so number line questions usually relies on intervals concept to solve. Okay, let's go on. Question 15. Okay, question 15. So there's 2 identical rectangles and 2 shaded triangles. Now this one will be a bit challenging. Okay, find the total area of the 2 shaded triangles. Okay, so why do I say this question is a bit challenging? Because looking at how the triangles are arranged on the rectangle, you notice it's a bit unusual. Okay, you notice that this is the one shaded triangle, which is kind of jutting out of this first rectangle already. So it's taking up space on the first rectangle and taking up a little bit of space on the second rectangle as well. Okay, and the second shaded triangle is just here, which is just inside the second rectangle. All right, so how then do I go about doing this? Okay, so to do this, okay, what I'm going to do is I am going to box up a rectangle, not the one in the question, but rather I'm going to box up my own rectangle such that this first triangle, such that the first black color triangle is within that rectangle. So how do I do that? Okay, so you can pick up your highlighters, do it together with me. We are going to box up this way. Okay, so before I do that now, maybe I need a pen to draw out first. So actually, I'm going to draw a dotted line down like this, such that the dotted line touches the corner of the first shaded triangles. The first shaded triangle, okay? So then I'm going to use my highlighter to highlight these as the rectangle to rely on. So notice that I'm highlighting my own rectangle like that. This is my first green rectangle that I've highlighted up, such that my first black triangle is within that green rectangle. Okay, I hope this is clear. And I'm going to use another color highlighter, all right, to highlight the second rectangle. So second rectangle is easy, again, is along the dotted line. So let me just re-highlight this. Okay, like that. All right. So with that, notice that, okay, I'm going to talk about the first green rectangle first. Now, if you notice the first green rectangle, the base of this triangle, right, is this line here. I will treat this as the base. Okay, and the height of this triangle will be here. This will be the height here. All right, so remember height must be perpendicular to the base and the height must touch the opposite, the vertex that's opposite the base. So the vertex opposite is here. Okay, so just, yeah, I know that the height touches here. So notice that the base is actually the full length of the green rectangle. And the height is actually the full breadth of the green rectangle. So based on the formula half times base times height, that means I can say that this triangle will be half of the green rectangle. So this is something that we are sure about. Okay, so I'm just going to write that down. Okay, so you should write that down also. So this triangle will be half of the green rectangle. So a quick trick to identify such cases is that whenever the base of the triangle takes up the full length of the rectangle, and whenever the height of the triangle takes up the full breadth of the rectangle, means I'm very sure that triangle is half of that rectangle already. Okay, so this is one way to look at it. All right. Now we're going to do the pink rectangle also. So pink rectangle actually is even easier to see. Notice that again, the length of the the length of the black triangle here is taking up the full length of the pink rectangle. And the height of the triangle, which I think is here because this is a right angle, right? Okay, for sure this is a right angle. So the height of the black triangle is taking up the full breadth of the rectangle, so of the pink rectangle. So that means I can be sure this triangle is half of the pink rectangle. Okay, so with that, I'm going to note that down also. So this is half of the pink rectangle. Okay, now if this triangle is half of the green and this triangle is half of the pink, that means I can say that overall, both triangles are half of the whole rectangle, are half of the whole figure. Okay, so that is something we can establish already. Okay, so I'm just going to type that out. Overall, right, both shaded triangles are half of the whole figure. Okay, so please write this down also. All right, and with that, that means we can proceed to find the area of the whole figure first, which I think no problems are because I know that these two are identical rectangles. So if this length is 14, here is also 14, right? Yeah, we talk about the original rectangles, not the green and pink one. The original rectangles, here is 14, here is also 14. So this whole stretch is 28. Okay, so area of whole figure, we're going to work that out. Simply is length times breadth. It's a rectangle. So length is 28 cm times the breadth of 10 cm, which is 280. So now I can find just the total shaded areas. Total shaded areas will be half. Like I said just now, shaded triangles are half of the whole thing. So if it's half of the whole thing, means 280 divided by 2. And that gives us 140 cm squared. So notice that I managed to solve this without having to work out the individual areas of these two triangles. I straight away find the total area of both shaded triangles by relying on the half logic. Alright, so in cases like that, it is impossible to work out the individual areas of these two triangles anyway. Because if you see the first triangle, I know nothing about the base. I don't know how many cm is the base. Same for second triangle, I don't know how many cm is the base here. Okay, so yeah, this is how you solve this, a little bit more challenging. Okay, and I'm going to go on to the next question. Question 16. Okay, some of you may find this challenging as well. Okay, so dots are placed at an equal distance from each other along the 7 sides of the 3 triangles below. So there are 7 sides, 1, 2, 3, 4, 5, then inside 6 and 7. Okay, the number of dots on each side of the triangle is the same and each corner has a dot on it. So when there are 4 dots on each side, as shown here, one side is 4 dots, 1, 2, 3, 4, then there will be 19 dots on the 3 triangles. So if you count together, there will be 19. Okay, so the question says when there are 20 dots on each side. So this is another scenario. Another scenario is if I must have 20 dots on one side. What is the total number of what is the total number of dots on the 3 triangles? Okay, So for such question whereby the corners are involved, what you should do first is settle the number of dots allocated to each corner first. Settle the number of dots, put that aside first. Okay, so what do I mean by that? So what I'm going to do is I'm going to count the number of corners. I'm going to highlight it up. Okay, so let's count the corners. So there's 1, 2, 3, 4, 5. Okay, so this is also a corner. The middle here is also a corner because the question says each corner of the triangle has a dot on it. So every 3 corners of each triangle must have a dot. Okay, so if you count this 1, 2, 3, 4, 5, you notice that means there are 5 corners. So confirm there will be 5 dots placed there already. Okay, and the next thing what I can do is you should start to calculate the number of dots without the corner. So let's call this side A, okay, excluding the corners. So I want to find out, excluding the corners, how many dots can I place in between the 2 corners? Okay, so in this case for side A, how to calculate that? You see 20 dots on one side, and this 20 dots is inclusive of the 2 corner dots. Right? So if it's inclusive of the 2 corner dots, I want to find the dots inside A, you have to use 20 minus 2. So that you know, excluding the corners, there are 18 dots that are placed. Okay, so this example is just for a reference when there are 4 dots on each side. But now I'm saying when there are 20 dots on each side, then we're going to recalculate from there. All right, so one side A has 18 dots, excluding corners, yeah? This one never include corners. Okay, so now I know that there are 7 sides, right? Correct, altogether there are 7 sides. So that means there are 7 side A's. So 7 side A's means I can take 18 times 7, which will give us 126 for this. So that means there are 126 dots on all the sides except the corners. Okay, now to find your total number of dots, now you just need to take the side dots plus back the 5 corners that you have. So 126 plus 5. And that gives us 131 dots then. So that would be the answer. Okay. All right, I'm going to go on to question 17. Okay, question 17. So we have this A, B, C, D is a square. All right, so if it's a square, I'm just going to mark out both sides first, like that. So here also equal, the 14 is here also. Okay, D, F, G is a rectangle, so a rectangle here. And then all the straight lines are shown. Find the total area of the shaded parts. Okay, so if you look at the shaded parts, notice that it's this like V-looking shape. Okay, and this shaded parts, right, you can actually break them up into 2 triangles. All right, so how do I see which are the 2 triangles I'm dealing with? So I'm just going to highlight this. So first triangle I notice will be ACH. Okay, so you can straight away work with triangle ACH. You don't even need to break up ACH further. Some of you maybe say, oh, ACH, can I break up into 2 triangles? 2 triangles means this top one and the bottom one. No need. Okay, you can just work with ACH as 1 triangle straight away alone. Okay, so I'm just going to color this as the pink triangle. So you can use your highlighters to color code as well. All right, and the next one will be triangle GCH. GCH will be the next shaded triangle we can work with later. All right. Okay, so for these 2 triangles, all right, you can check whether are you able to easily achieve the base and the height of these 2 triangles? If can, then you should straight away work with the shaded triangles. If cannot, then you work with the unshaded triangles instead. All right, so let's check first. Of course, if you can work with shaded parts straight away, that is the best. Okay, so first yellow triangle. I think yellow triangle no issues, right? Because I noticed GC and CH will be the base and height. That one easy to tell because there's a right angle here. So GC is 13, height is 8, so no problem. Half times base times height, you can straight away apply. All right, now then the pink triangle, ACH triangle. Pink triangle, which side will be the base? So I think the best side to treat as the base is CH, of course. Okay, because CA, I don't have the measurement. AH, I also don't have the measurement, but CH, I do know it's 8 centimeters. So I will treat CH as the base of a pink triangle. That will be the best. Okay. Now you might want to rotate your paper around. Rotate your paper around such that CH is at the bottom of the triangle. Okay, so if you have figured that out, you realize if I treat CH as the base, your height of the triangle will actually be this one. This will be the height, AB. Okay, I can't rotate my paper now, but I hope you know what I'm trying to say. So if you turn it around, then you realize that, okay, this is the extension base. Okay, I will extend this base, dot, 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 like how you did in your basics. And then AB serves as your perpendicular height, perpendicular to the CH here. And you know that AB will be 14 cm. So no issues, you see, my base and heights, I have the measurement. So straight away, we can work with the shaded parts then, very safe. All right, we shall do that now. All right, so let's do area of triangle, the yellow one first. Triangle is GCH, right? Okay, so this is the yellow triangle. All right, so half times base times height. So base is your 13. Height is your CH, which is 8. Okay, do the calculations and you should have 52 for this. All right, now we're going to do for the next triangle as well. So for the next triangle will be area of triangle ACH. Oops, sorry, let me just get back to that. Okay, here. So area of triangle ACH. Okay, this was the pink one. All right, so half times base is CH, like I said, which is 8 cm, times the vertical height, which is 14. So this will give us 56, if you calculate that out. So just need to add them up now to find the area of the shaded part. So this gives us 108 cm squared. Remember, you need cm2. Okay, we shall move on to do the last question. I think it's the last question. Yeah, the last one. Okay. Okay, question 18. Mr. Tan baked 440 apple pies and banana pies at first. He sold 3/4 of the apple pies and 2/5 of the banana pies. The number of banana pies unsold was twice the number of apple pies unsold. So which pies did he bake more at first? How many more? Okay, so for this question, notice that I have a lot of units information. The 3/4 is units, 2/5 also in terms of units, and the twice also in terms of units. Right? Okay, so how to do this? So what you can consider doing is you can translate all those units into a ratio. So I should have 3 sets of ratio to be presented. First set is this one, second set is this one, third set is the twice. Okay, so we can work on that. So please do not go and make denominator the same. I should highlight this first. Do not make the two denominators the same because each denominator here refers to different types of pies. If you make denominator the same, that means you are saying number of apple pies equal to the same as number of banana pies, which is not true. We do not know. All right, so do not do that. Okay, so let's settle apple pies first. So I'm going to call that the apple pie ratio. Just underline like that. So they say he sold 3/4 of the apple pies. So you can actually compare sold apple versus the unsold ones. I will need unsold information. It will be helpful because later I can do my common base with this twice unsold. Correct? Yeah, the number of banana pies unsold was twice of apple pies unsold. So later we can settle that. So sold versus unsold information will be useful at this point. Okay, so he sold 3/4 of the apple pie. So I sell 3 units, right? Now, if I sell 3/4 of the pies, means I did not sell 1/4. So that means your unsold should be 1 unit, not 4. Be careful. 4 is the total apple pies. Okay, so when you translate a fraction to a ratio, be careful of your understanding of the units first. Okay, we're going to do the same for banana. So banana, same thing, I'm going to write sold versus the unsold. So I sold 2/5 of the banana pie, so sold 2 units. Unsold, if I sell 2/5, means I did not sell 3/5, correct? So if I didn't sell 3/5, means unsold is 3 units. Okay, and lastly, the twice, the number of banana pies unsold was twice the number of apple pies unsold. So this is bananas unsold versus apples unsold. So actually you can just write it as B unsold versus A unsold. Okay, just lay out like that. I think it will be clearer. So bananas unsold was twice, so that will be 2 units. Apples unsold is 1 unit. Okay, from here you just need to do your common base. So I have 3 ratios here, 1, 2, and 3, 3 sets of ratio. You should expect 2 pairs of common base then. Okay, so let's identify the first pair of common base first. So first pair of common base, notice that it would be your apples unsold because they are both referring to the same information, right? So apples unsold, I highlight in pink. Okay, so apples unsold both shows 1, 1. Okay, so at this point, safe. Now, then the next pair of common base will be what? Next pair of common base will be your bananas unsold. You see? So yellow is 1 pair of common base, pink is the other pair of common base. So let's look at the bananas unsold. Notice that 3 and 2, we have to make them the same. So 3 and 2 common multiple is 6. Okay, so this side times 2 become 4 to 6. The other ratio times 3. All right. Now check for apples again. Notice the apples now change to 3, the unsold. So apples unsold change to 3 means this apples unsold, I also need to times 3 to this. So this one also times 3, 9 to 3. So go on to underline your common base, circle the other pair of common base. Okay, 2 pairs of common base settled, done. So once this is done, you can now answer the question, which pies did he pick more at first? So I would like to find out apples at first. How many units? Okay, so apples at first means the apples sold units plus the unsold one, so 9 plus 3. Do not use 3 and 1 anymore. The moment you do common base already, establish the common base, always use the most updated units in that ratio. Most updated is 9U and 3U. So 9U and 3U, add them together, that's 12 units. Do the same for bananas at first. Okay, so bananas at first will be sold plus the unsold 4U plus 6U. I think we can see the comparison from here already, right? 12U versus 10 units. So which one big more at first? Of course, will be the apples at first. So we're going to circle this. Okay, now they ask you how many more? How many more? So you need to solve using the 440 here. All right, so once you have settled your common base unit settled already, go and reread the question to see which value we haven't got to use. This one we haven't used yet. So 440 is at first, right? So together, I know this is 22 units already. So this 22 units is your 440. Then of course, find 1 unit. They ask you how many more. How many more means the difference between these two values. So 12U and 10U, the difference is 2U, right? 12U minus 10U. So just work out 2 units, which is 20 times 2. So that would be 40 more apples than bananas. Okay, so using ratio method to solve this will be very useful because if you master the skill of common base, then actually this is pretty much quite easy. All right. Part B asks what was the total number of pies sold? Okay, so sold, simple. If you want to look at the sold means you look at the sold in the ratio. So apple sold is 9U, banana sold shows 4U. Okay, so just add up 9U plus 4U. So 13U are the sold ones, total sold. So just work out 13U then. Just now 1 unit you found is 20. So 20 times 13. Okay, so that will be 260. All right, so that's all. Thank you very much.